This talk is for Subnet 4 primarily. At the end, maybe Sammy and other people on this call, we can talk about the conversation, I think very interesting conversation we were having earlier in the route channel about root stake, dividends, et cetera, et cetera. If people want to participate in that, we'll have that conversation at the end. But either way, without further ado, hey, Rob, Josh, welcome to the call.
We're going to let Josh lead the charge on this one today. Our newly promoted CTO of Manifold, Josh Brown.
Hello, hello.
Let's give a round of applause for him. Shout out. We had a slide deck prepared, but we cannot share our screen here. We just got this camera, we wanted to show off the new crib, There we go. All right. I think this is working. Zoom fast.
There we go.
It is amazing.
Yeah, so it's great to see everyone. I'm gonna share my screen really quick. One moment. Apologies for the technical difficulties.
There we go.
All right.
We can see it.
Hello, everyone. My name is Robert. My online handle is Caro. This is Josh. His online handle is Josh. We're going to be talking a little bit about Subnet 4 today. I'm going to give a good little bounce pass to Josh, and we're going to get into it. All right. So for those who don't know us, all right, I'll let you do that.
We're Manifold Labs. We run Subnet 4 here on Bittensor. Manifold was founded by Rob here, one of the old people at OpenAI. We not only run Subnet 4, we also run a validator on a couple subnets. And then right now, Subnet 4, something we're really proud of recently is we're up to about 14 billion tokens a month, and we're hoping to be able to scale that to a couple 100 billion, if not a minimum of 100 billion by end of 2024.
Yeah, we're going to get to 1 trillion tokens is our goal. Okay, 1 trillion or bust.
So one of the first things we built with Subnet 4, one of the things we want to do is really showcase that you can take some sort of commodity that you create on Bittensor and really turn that into an actual product that people could use. And so our first iteration of that was Sybil.com. So Sybil goes out, uses SeerXNG, which is like a decentralized search engine, or it's a meta search engine. So it queries a bunch of other search engines, gets the results back, and then we feed those results to a large language model, which is Bittensor, the Subnet 4 miners. And then that gives you a little summary of whatever you searched for online, kind of like a knockoff of Perplexity, except it's free for us. It's super cheap to use, for us and for us to run. It's now fully open source. Any validator or anyone that's interested can go take a look at exactly how it works. The front end's open source, back end's open source, whole 9 yards. Right now, it uses React on the front end. And then one of the things we were very proud of is using Go as the back end that interfaces with the miners. Specifically today, in the last week, we've done a lot of work on Targon Hub, which is currently the core that powers Sybil, and being able to do these fine-tuned controls on stuff like timeouts, and being able to know, okay, how long should a TLS handshake take before a miner responds, and how can we make sure that as much time as possible is not wasted. And we really know if we query a miner, are they responding correctly, and then can we make sure that we save those queries, or what miners fail a request, so that later on we can score those organic queries and really start punishing miners for not taking organic requests, and giving miners big boosts for taking organic requests. And so now that all that infra's in, it's all open source. So yeah, go take a look. It's some really cool stuff. So one of the things that powered this, that was another thing that we're very proud of, is the Epistula protocol that we made here. I think our video is bugging out a little bit, but
it's good.
Okay. So Epistula, it's different than the original Axon interface that most people are used to. The reason we wanted something different was some of the new Bittensor versions were erroring, or just we would try and update versions and the Axon would break even though we hadn't necessarily changed anything, and it was just becoming very frustrating. And so we went to the drawing board and said, okay, what's something we can make that not only serves our needs right now, but will serve everybody's needs, and will really be something that can last for a long time. And one of the biggest things we wanted was something that was very opinionless. So it's much more opt-in than it is opt-out. And what I mean by that is there's no part of the request that you really have to look at or that you really have to verify in order to use a request. So miners can trade in as much security as they want for speed, and same for validators, or really any entity that's using this whole protocol. And that's another thing that we wanted to do with Epistula, is specifically not make it a package. We wanted it to be more of just a protocol, a definition of standards, and let people kind of implement that however they want. And so that's what we use in our Go API right now, our validators. I think on the next slide, you can see this is essentially all the code minus the create header hook that we need to interface with our miners. Our miners themselves are OpenAI compliant, and this is all because of Epistula. As you can see, you just create your OpenAI object in Python, and then on the HTTP client, the only thing that's needed to really make it work with Epistula is that last function that just takes in your validator hotkey, your Axon info, or like the hotkey of the miner, and then the model you're running. And with those three things, that hook will run right before any OpenAI request is sent and add in all of those headers to the request. And that's all the miners need.
And so this interfaces directly with a miner. So this query hits a miner?
Yeah, on the top there, you'll see axon info equals metagraph.axons, and then you put in the miner number. That's in our subnet code. We use the OpenAI package to query our miners.
And what is OpenAI, this client, doing underneath the hood that's different than the Axon?
That's it's an interesting question. So it's not necessarily doing anything that the Axon was doing. The big difference here is what is Epistula doing that the Axon interface didn't do. So here, the Epistula protocol doesn't care what the body looks like at all, because the hashing and the signature is done on the byte level of the request body. So right before the request is sent, whether it's a JSON object, whether that's an image being sent as a post request, if there's no body at all, it doesn't matter. It's whatever the bytes, if any, of the body exist, it'll sign those. And so we can use OpenAI or the OpenAI interface specifically because Epistula doesn't care what the body looks like. And so we're not necessarily using OpenAI for like security or anything. It's more of just how much benefit it gave us from a developer experience perspective, where I now have all of the OpenAI like typing built in, errors. I have all these different things built in, and it makes it much easier to just build products off of our miners in general, knowing that they're OpenAI compliant.
Right. It's just a standard, and you guys are porting yourselves into it. Wait, so you're telling me that the Axon interface is not a well-known standard?
Well, and to be fair, like neither is Epistula. Like it's just our little thing. But the difference is ours is it's just a protocol, and anyone can go read exactly how it works under the hood down to like the very lowest level of how the signature is being made. And that was my personal problem with the Axon interface, was it was all a big black box. And I'm one of those people where if I'm writing something, I really want to know how it works. And so that's what we made, something where people could really understand how it works and really take advantage of it as much or as little as they wanted.
So little caveat here, well, not caveat, bit of a side story. Josh, when you first joined Manifold, you wrote a scathing review of the Axon. It was like the first real hit piece that I ever really like cared about, ever written about Bittensor. It wasn't really a hit piece. It was just really honest review of the Axon code, which, you know, to be fair to us, we built very quickly as a plugin, and we always knew that it was going to be ripped out. So funnily enough, just the other day, the Datura team figured out that there's actually a 40x increase in speed that you can get by just removing the hashing of the headers in the Axon protocol in Pydantic. you just get a 40x increase in speed. So there's a lot of overhead in that protocol, and the reason we had it was because we thought that, hey, like maybe these things are not going to be so speed dependent and for everyone, but for your use case, it just makes so much sense, right? Like it's all about building a standard that anybody can use, anybody can plug in, like directly into Cursor, for instance, or any application front end, and then behind the scenes making it blazingly fast. So yeah.
Yeah, and that I trust me, I remember writing that. One of the first things I did when I joined Manifold was reverse engineer the Axon interface itself, and that was kind of my first deep dive into Bittensor, was just like really figuring out how that worked under the hood. And I just remember being at a coffee shop till like 2 a.m. trying to figure out how on earth this hashing is done and what I need to do to write this in Go. And yeah, it took way too long, but anyways, that was a whole fun trip. So now we're at Targon Hub. So this is another thing we've built. This was actually built after Sybil and before Epistula, but now Sybil uses Targon Hub. We removed Sybil itself used to query miners directly, and now Sybil will proxy to Targon Hub, so that now all organic queries, whether they're from Sybil, whether they're from someone using Targon Hub as a OpenAI compliant endpoint, what have you, they all go to one central database. And so one of the things that we're building, hopefully we'll start, if not get it done next week, which I'll talk about this in a little bit too, is some sort of endpoint that sits next to our ingester, which we'll talk about. But essentially, it's something that validators can not only send validators could not only send synthetic requests, but any validator could grab organic requests in real time from this node that will run and connect to our database that has these organics. And then again, this is all optional. Like a validator could plug into this system if they wanted to, and if they didn't want to be a part of this organic system and use their own, they could absolutely do that too. And this will all be open source, of course. But we'll hopefully be able to start really scoring based on organic queries even more than synthetic queries, which is one of our biggest goals. And I think for a lot of these usage-based subnets, I feel like that's like the general goal, is to really move off of synthetic data and start really getting like a proof of concept from organic data. So Targon Hub has been amazing. One of the really cool things is using this Epistula protocol and writing it in Go, and really being able to just have so much more of a low-level understanding of what's going on and be able to use a lot of these primitives. One of the things I was working on today was really getting into the weeds on what types of different timeouts we use when interacting with miners. A lot of miners, how do you tell the difference between a miner that's just taking a little bit to respond versus a miner that's not there at all? And it's like, you could have a timeout for the TLS handshake or for time to first byte, or you could have a timeout that kind of extends itself every time you get a byte back. All these different things that are just much easier to do in Go than Python. And also just being a compiled language, getting the speed benefit from that. It's been a really fun time. And again, all open source for anybody that wants to go look at it or even run their own. And being in Go and being so lightweight, it's extremely cheap for us to run. We could run one of these Targon Hub backends on an a Linode instance for $5 a month easily. They're very, very, very light instances.
And so this API that you wrote, or this toolkit, it's wrapped in Python, correct?
No, nope. The Targon Hub itself is purely in Go and nothing but Go.
And to what degree does it connect to the Bittensor blockchain in Go? Are there like Go versions of the metagraph and things like this?
No, sorry. So, okay, you are right. There is a Python sidecar. It's its own Docker image, and the Python sidecar will query the metagraph every, I think I have it set to 30 minutes or so. And that will look at it'll load in the hotkey and cold key. It'll look at all the miners currently on our subnet. And then that sidecar will query all the miners and basically ask like, hey, what models are you running? And then save that in a Redis database. And then that's how we know what miners to hit. So you have this Python sidecar, very, very small. It's no more than 100 lines of code, I think. It just sits there, grabs all the miners, their IP addresses, ports, and then what models they're running, which it'll query itself. It'll query each miner with the validator hotkey, post all that to a Redis database, and then when we get a request in from or an organic query, the Go API will query the Redis database and say, hey, give me some miners that are running this model, and then go query one of those miners for that model, and then save it all to a database that we can then send out to validators later on.
Cool. Would love it if you wrote, and I'm sure you're a very busy man, Josh, but to write a version of the Bittensor API and Go for people that wanted to build really highly performant validators and miners, that would be a huge, real gift to the community.
Yeah, absolutely. I would love to do that too. I wanted to do that a while ago. I think the biggest roadblock I have, and would love some help on, probably from like the OTF team or something of the sorts, is how the storage like hashes are calculated. I believe I tried writing something in Go and I couldn't quite get the
RPC call.
Yeah, the actual, like when you're calculating the storage hash.
That's a longer conversation. We won't go over it here on the call, but it's something called scale codec that you need to
gotcha.
learn.
Yeah. No, I mean, if you guys are willing to work together on that, I'd love to get something going for that. That'd be sick. I would love to make a Go, or maybe not necessarily a Go, but some sort of compiled CLI. I know I've been screaming about that forever.
Yeah. Rust would be the best. But let's move on. Let's continue with this.
So that's a lot of the things we've built on top of Targon over the years on Subnet 4. And so I want to take these last few moments here to talk about Targon V4. We just released, I believe, this past Monday, with some really, really cool new features. We can now have on-demand per validator models. So any validator can choose what model they're querying miners on. And this doesn't have to be one model. It can be any number of models, as long as they all can fit on the node that the validator is running. It'll work for that validator. The validators themselves almost act like super mini Kubernetes controllers. It's not literally using Kubernetes, but it's Kubernetes-esque in the way that the validator itself is managing the lifetime and life cycles of a bunch of different Docker images, including it takes care of calculating how much GPU space it has left, how much GPU space it needs for a new model, all this sort of stuff. And right now it's working really well, and we're really happy with it. And we still have a lot of plans. One of the things we want to do is enable GPU sharding, so we can start querying miners for 70 billion models. We have some more plans that'll make validating more efficient. We hope to be able to do what you can do on an 8 box on a single A100. Which would be awesome. It would bring costs down for all the validators while keeping the same amount of models that we're querying. So it'll be really fun. We also have some cool stuff in here where miners will report what models they claim they're running, so that we can kind of optimistically query miners and not waste time querying miners that aren't running a given model. The coolest thing that this really opens up for us, like we've talked about, is model leasing, where now we can actually sell the ability to organic users to run the model on top of charging them for actually querying that model. So if there's some new model that came out and people know that they can run it on Subnet 4 for much cheaper than they could query it anywhere else, they could pay Targon Hub or whatever other validator wanted to implement this whole stack. I'll say whatever amount of money, and then we just say, okay, cool, we'll host this model on Targon for you on one of our validators, and now miners will be incentivized to run that model. So that's really, really cool. We're super excited about that. And then one of the last things, go ahead.
So Josh, this is a big innovation for the subnet, I think. Is there any other place on Bittensor where this is possible today? First off?
The model leasing, not to my knowledge. Yeah.
I don't know anyone who's doing model leasing.
And like, where else could you do this? So like, if I go to Together AI or other inferencing services, maybe like I can do this on Hugging Face, right? Is there like a comparable on Hugging Face for the same thing?
Not
good.
I'm sorry to jump in here. I don't think that there's the only thing I'm familiar with that does something similar is like what's known as like GPU-less providing. So like RunPod, for example, will do, or it's like serverless GPUs. So it's like, well, you can run a model on RunPod, but like you will only be charged for like the inference time itself. So that's like probably the most comparable. Hugging Face does have a inference endpoints, but just in my experience of using it, it's not very good. It's either like very slow, like you're running it on CPUs, or if you do rent like a GPU, you have to keep the space like running and stuff. This is something that we're really excited about pushing forward, just because it'll enable anyone to run.
You can do it in other places, but I reckon there isn't anywhere else in the world that you can do it, and then there's an incentivization mechanism that's forcing the speed of inference on that same model that you're hosting at the same time, right?
Sure, and that's another cool thing that this update really lets us shine with is there's no more glass ceiling on our incentive mechanism. Like there's no theoretical max a miner can get. We can always keep pushing out new models, and miners are always incentivized to figure out new ways to spin up models. What's the fastest way to manage this fleet of models? We hope to get to a point where eventually I want to be able to post a model on Targon Hub, which is where a lot of the validators currently look to see what models they should run to stay in consensus best. But I would love to see miners really start to figure out how they can, the second a new model gets pushed to Targon Hub, or like the second that someone leases a new model, miners are already ready and running that model. I think that there's so much room for miners to innovate here. The skill ceiling really has just gone up exponentially. It's been really cool to see how our miners are reacting to this. I'm super excited once we really get organics deep in here and start scoring organics much heavier than synthetics to seeing what we can build with this. I think we're going to be able to build some really, really cool stuff.
So I'm a bit of a geek, and there's also a lot of subnet owners and developers in the chat and in the audience here. Like, can we talk technicals? Like, how did you do this? Because this is no easy feat.
Sure. So the Python or Docker has actually some pretty good it has a pretty good SDK for Python specifically. And I've been working with Docker ever since I got into programming in general. I found it within like a year of starting getting into programming and had a good bit of experience with it. And once you know a lot of the fundamentals of how Docker containers work, specifically not Docker Compose, but actual just Docker itself, like what's the difference between an image versus a container, image hashes, all these different things, labels. If you have a good understanding of that, it translates to Python in their Python SDK really, really, really well. And you can start to get pretty confident with having a Python application control all these other systems. So our validator itself will start up a Docker client, which is essentially your central control point for spinning up Docker containers, pulling them down, whatever. And then from there, we use, I believe I have Python run the NVIDIA SMI command on the host, and then grab the output and then parse that output as text. And so from that, we can grab how many GPUs there are on the validator, how much memory is free on those GPUs, and then what the total memory is on each of those GPUs. And then we can use that list to then say, okay, well, if I have 40 gigs on GPU 4, then I can run this 12 gig model on GPU 4. And then we say, okay, let's spin up a Docker image, and we have all these different environment variables. I'll tell the Docker image it specifically needs to run on that GPU. And then the validator itself will keep a list of what Docker images it knows about. And that's another part of the process is when it starts up, it'll scan all the Docker images that are labeled with a label that we put on those Docker images. So that way, if say someone is running a subtensor on their machine that's running our validator code will not touch their other Docker images. It will only manage Docker images that it sees has labels that it would have put on those images. So that, for instance, we put the port number as a label, we put the model that it's running as a label, and then I believe we also set the image name as the model it's running. So there's various techniques we can use to when it starts up, see what's running, and then after it's running, see what else it needs to be running, start those containers, and then keep track of all that in memory as like a model to port mapping. One of the other things it does is when the container starts up, we add a health check. So as the container is starting up, it takes time for these model weights to get into memory. And so before the validator starts querying people, it'll wait and check each Docker image until it sees that the model weights have been loaded into memory and the API endpoint has started up that we can send a verification request to. And then once that's up and running, we know for sure the LLM has started up, the weights are in memory, it's alive, it's all good to go. And then at the same time, we can make sure that if it took too long or if it failed to start up for whatever reason, if there wasn't enough GPU memory for whatever reason, the validator itself will know and be able to not use that one and like kind of remove it from its memory.
So is this then advertised to the chain? So the validator says to the chain, like, I'm running this, I'm validating this model and this model and this model, and these are on my.
There's no gossip. Each validator is fully independently controlled on what models they want to query miners with. So if some other validator wanted to validate on our subnet and they really want to build a business out of code completion and they have this really good private code not private code completion model, they have this really good code completion model that they really want miners to run, and let's say they're running on like a big H100 or an A100. That validator will then convince other miners to run that one model, and now they'll have access to just that one model, and they don't necessarily need any other validator to be running that. They just need some miners to pay attention to them and run that model.
How do the miners know that they're running those models?
When the validator starts up, after all the Docker images have been loaded, the validator will go through every miner in the network and then ping them and say, hey, I'm this validator, and these are the models I could potentially ask you for. And then right after that's done, we'll then go back through, or actually at the same time, I believe, we'll first tell them what models we have. And then right after that, we'll ask them what models they're running. And then the miners themselves, it's up to them to implement the logic of responding with what models they're running and intaking what models we're requesting. And so this is where I see a lot of innovation on the miner side. I would love to see some miners that do the same sort of Docker setup where we can ping them that, hey, I want these models, and they instantly spin up some Docker images off the bat. That would be really, really, really cool to see. And I think honestly, there's some miners out there that can do it, and we have the boilerplate code in our validator now. Essentially, they can go rip it out.
So one thing that comes to mind in this design is that the miners will be limited in some sense by the GPU sizes of the validators, right? Whether or not the validators are very incentivized to run, a lot of machines is kind of up for, is really a question on a lot of people's minds right now. So is there a way of moving past this system where you put more work onto the miners and the validators don't have to run a replica in memory of every model that they're validating? Is there a way that you can imagine that working in the future? Do you understand the question?
Yes, yeah, absolutely. And this is something we've thought of, and we already have a solution for it. It's just a matter of us implementing it. I think the biggest thing we want to focus on right now is getting organics in. I really think that's our next top priority is really getting these organics weighted really heavily. And once we have that, we plan on doing model scheduling. So the validators will keep an internal schedule of all the different models they could potentially run. And then we'll use the same sort of Docker system to dynamically spin up and down in real time different models. So let's say a validator could have 10 different models ranging from let's say 30 gigabytes to 12 gigabytes each, and they're running on a single A100, the validator would just do some math and figure out, okay, I'm going to send requests synthetic and score organic, or I'm going to send synthetic requests for every type of model, but then I can spin up any given model and then ask or keep my own records of the synthetics I've sent from that synthetic model, or get queries from our little node that we were talking about earlier, where validators can ping it and say, hey, I'm currently running this model. Can you give me some organic queries from this model? And then we can send them those back, and then they can validate those really easily. So it's essentially, instead of having all the models running at the same time, you just spin up a model, validate on that model for a little bit, spin it down, spin up the next model, validate on that model, and rinse repeat. But without the miners knowing, like, you'll always query the miners on different random models. So yes, that's our solution for that.
Effectively, you don't require fully redundant deterministic validation. You use a sort of pseudo-random design. Which I think is, my guess is you don't need to have 100% redundancy to still get what you need. You know, you can.
Yeah, we don't have to verify every single response. And again, this is why we want to really start scoring organics harder. Is we already have an insane amount of throughput. Like, it's in the realm of, like, again, billions of tokens a month we're sending these miners. So they're getting plenty of challenges. And one of the cool things is organics look extremely similar to synthetics. They're a little easier to tell for various reasons. Our top miners all know, we've talked with all of them. They'll see us doing rate limit tests and seeing how hard we can hit them. And we've had some of them come back and put in throttles on us, rate limiting us in return, which has been funny. But yeah, they're all ready to handle such an insane amount of tokens. There's no reason to validate all of them. And once we start validating these organics, it'll really put the pressure on them to never, ever miss a query, or else they'll get essentially zeroed out.
Properly generating synthetic requests that match well with organics is a really difficult task. How are you guys creating these synthetic queries? Like, what's your pipeline? What's your style?
So before I answer that, I would actually counter with, synthetics are important, but I think the way I really view synthetics is that they're a jump start, or like they're used to
it's like an engine start.
It's like an engine start to get these, like, new miners that have zero incentive up to a point where they're eligible to have organics. And then that's where organics would take over, and we wouldn't even really use much of any synthetics on them. And at that rate, they're incentivized to respond to synthetics, no matter how good or bad or close to an organic it looks like, because once they get hit with an organic, that's when the real game starts. And if you can't survive organics, you're not going to survive an ecosystem.
Right.
With that said, right now we use, I forget what exactly the data set is, but I think it's 9 million rows, 60 million rows, something of the sorts. It's a very large data set. And then we take that data set, generate it, or we grab one of the questions from it. We run it through one of the models that you're using to verify. So actually, like, if I query you with a, like, let's say, meta model, I'll actually create a question from the question in the data set from that model first. So I'll say, hey, LLM, pretend you're a search engine, or pretend you're like some person, and make a question similar to this question I'm giving you that would be formatted in this way. And then your name is going to be this name from this country, just to add a little bit of extra noise. And then the LLM will come back with a more random question. So it has a little more noise. So we turn up the temperature a good bit. So this way it's really hard to detect, or really it's very rare for there to be duplicates, because we're running it through this LLM with high temperature first. Plus you have, like, the different name in different country. And then we'll take that question, format it again, and then send it out to miners as a synthetic. And then in that whole process, we'll also change questions will either be sent as chat completions or as regular completions. So miners are actually getting challenged on both possible endpoints too.
And it's very, it's going to be great to have this data set of organic requests as well as the organic seed, randomness seed for these questions when you're doing synthetics later on, right? You can use the actual distribution of questions as, as the random seed generates synthetics later on.
Yeah, absolutely. We could make our own data set out of these organics for sure. Yeah, we have, I think right now, even with the synthetic data, we could build a data set off of all the challenges we've sent to miners. Again, have that level of randomness from being sent through an LLM in the first place. And we currently save every single response or every single challenge and response from every single miner and every single validator. I think right now we have somewhere in the realm of 700 gigabytes of responses and challenge requests. And it's been really cool to watch that database grow and see how miners respond over time and seeing all the stats, and also figure out how to use indexes properly and manage a database of that size. It's been really interesting.
Great. Cool, Josh. All right, well, let's move on to the there's more on this slide, so let's dive in.
Yeah, so our last slide, our roadmap for moving forward. We want to build a general LLM inference service. It's what Targon Hub is aiming to be, and we'll build it out to be. And like we talked about, users will be able to lease models from validators. We're hoping to compete with Together AI, Open Router. These are just companies where they basically plug into people that offer LLM inference, and we're hoping to just basically, the miners will be the providers, and we can say, hey, I want this model, and our miners will spin up that model and start serving it. General OpenAI schema compliant. We already have a lot of this done.
I think that's done.
It's done mostly. There's still some things we want to add in. One of the big things I was talking with some miners about is OpenAI already has a standard for listing models that are available. So I want to change our miner endpoint itself to have the same format. I think that would be cool. And then there's a couple other things. I know we need Targon Hub. Apparently some applications have built in, for whatever reason, API key parsing, and our API keys on Targon Hub are not exactly like OpenAI keys, so need to fix that. But we're pretty close to being like 100% OpenAI compliant, so that's really cool. And then one of our future goals that we've talked about too is achieve at least 75% organic scoring percentage of how many organics we're scoring to synthetics. I think that'll be a massive step for us and the ecosystem as a whole, just being able to have a product living on Bittensor that truly is being used and miners are being scored on real people using the product. And then one last big thing that we have to announce is a new project we've been working on internally called validator voting. Rob, do you want to explain this?
Yeah. So, one of the things that we've been thinking about, a lot of the frustrations that a lot of new subnets have, or subnet owners in general, when it comes to the sort of opacity in terms of like how validators are setting weights. And we've seen innovations come out of like Miner Union and Datura, where it lets people set their own weights based off of their stake. This is analogous to like STAO, which is like a precursor or predecessor to DTAO. And so, but not all validators have implemented this. And so we've built at Validator Voting on our GitHub, an open source version of this, so that any validator can be able to run their own sort of STAO, just like how Datura and Miners Union have. We think that this is really positive for Bittensor. And so we're really excited to release this as an open source project. We're still doing some work on it, right? But obviously we want to work closely with the validators that do want to implement this, so that they can remain competitive with Datura and Miners Union. And yeah, we're really excited about building out Targon Hub and really trying to drive, like it's for us, like if you think about what we do for the miners, right? We define these objective metrics that they need to maximize. And so for us, it's kind of the same way, where now as Manifold, right, our objective is to maximize organic tokens, right? So right now, if like, for example, on Open Router, they're doing about 60 billion tokens a week in organic, responses across, 200 different models, right? Well, we want to be able to do 10 times that, 600 billion tokens organic across 200 models. And so, that's kind of like a mission that Manifold's embarking on. So, really, really exciting updates here from us. And shout out to Josh. Do we have another slide? Or no, that's the end of the slideshow. Yo, shout out Josh. Yo,
Shout out. Well done, Josh. Very cool to see that you're pushing into the open source implementation of the STAO design that Muv created. The Muv revolution is upon us. So the idea here is basically like anybody can take this and run this on their validator, and it'll just or automatically turn it into an STAO validator.
Yeah, exactly. So, or it's just it works very similar to how Datura and miners unions work. So, like, if you're a validator right now, you could run this and allow people to delegate to your validator, and then vote for the weighting on the subnet that you like or that you prefer. I think that this is and I know price talk is banned in the Discord, so I'm not going to do price talk, but I will talk slight tokenomics, where it's like, okay, if you incentivize people to hold their TAO by voting for the subnets they like, I think that this has positive action on the price. Now, obviously, we're not talking about price, but I'm just saying that we think that it's a really good thing for Bittensor to kind of allow people to have a voice, no matter how big or small you are. We think it's really important to allow, Josh has massive form. This guy works out, But so we do think that these types of implementations, shout out to Miners Union. Love those guys. I think that what they did was a really great idea, and it's really powerful for not just for themselves, but also for the entire Bittensor ecosystem. If you look at the benefits for the validators that are here on the call, if you look at the benefits of implementing this, Datura received, I think, almost 200,000 TAO in delegation in a week from implementing that, which is hugely beneficial to their validator, right? So by empowering people and giving them a voice. So, I would say that it's a net positive for validators. It's a net positive for the community, giving them a voice, and overall a net positive for the project.
I think so too. I think that we wanted to implement this meta on the chain, and then we decided that we think it's kind of an intermediate step before dynamic TAO. So let's not just do two massive upgrades. Let's just do one massive upgrade. But then we were very happy to see it actually just be implemented on the top of Bittensor, right? Like you can't hold back a good idea. You can't hold back people from trying to build open source alternatives and ways of organizing ourselves. I think that will explode when we bring smart contracts to the chain in the next little while. That being said, I do think that it game theoretically will explode at a certain point. And it won't last too long. That's my perspective. That's my opinion. But I am actually really interested to see how it plays out. And at least people are a lot of new participants in the weight allocation decision are getting a choice now. And so that's I think the most positive thing is like, hey, let's get rid of the oligarchs and let's see what can be done in a different level. So hell yeah. Shout out to Muv.
Shout out to Muv. We love Muv. So we're in terms of what we're doing, like on Targon Hub, we're working on maybe getting bridging that to like hub.civil.com. We want to release a new upgrade for Targon Hub here shortly. Don't want to say too much on that yet, but we've been working very hard on that. Some of the guys here at the table. And so, really like just increasing, like, I saw some activity on Twitter and some conversations on Twitter the other day where it's like people are asking for front ends and like, how can I use Bittensor and these sorts of things, right? And we really want to like take Bittensor to the next level in terms of its usage. And one of the best ways to do that is by integrating with all of these different applications that are using OpenAI right now. If you go and you look at like on OpenRouter, right? I mean, what is it? LLM Tavern or Silly Tavern is, doing, billions of tokens a day in organic queries, right? And so how can we go out and get those people using, Targon Hub or another validator service on Bittensor, such that the number of people that are using Bittensor in like a very, organic, natural way increases. So this is what we're really focused on, and Targon V4 has been a really great push. Thank you, Josh. Let's get a round of applause for Josh. Awesome. Yeah. So, yeah.
Thanks, Ben. Are we going to get to see this on Cursor anytime soon?
Yeah, I mean, so Cursor has a bug in it right now. I can share my screen to where it works. Like we have it working right now. Let me. Okay, let me share my screen really quick. Okay, what is going on? Sorry about this, y'all. Man, I usually never have such technical issues, right? But here's some code really quick. So here, as you can see, this was a model that we just released. I actually don't know if any miners have picked it up yet, but this is a coding model, 7 billion coding model that we just released. But we do know that Hermes 3 is working. So as you can see, if you want to plug it into Cursor, you can, change your OpenAI base URL to hubapi.civil.com. There is an issue with the way that the verify API keys is working right now inside of Cursor. We shot them an email because when you click verify, it says failed to fetch, right? But on our API, we don't get it. So it says and we ran this command and it worked. So we sent them an email. But like, let's say I have this page right here. We have Alex at Manifold Inc. This is, kind of doxing some code here real quick for the new Targon Hub. But so I can just say remove Alex and replace it with Robert, and then hit enter, and then it's always live demos that break. It literally just worked. Oh wait, hold on. Let's see. And then okay, yeah. So then I click that, and then yeah, boom. And then there you go. So it made the change right there in Cursor. So this is using the Hermes 3 that's running on Subnet 4 right now and going through the hub proxy. So this is something that, you can integrate with Cursor as soon as Cursor updates that issue with the verify, because it won't save the API keys. But other than that, it works. That's
amazing.
Yeah, so it works in Cursor. It works in pretty much anything that uses the OpenAI package works with this. So all you have to do is go to targon.civil.com, sign up with an account. You'll get 10,000 credits for free. And you could start using it immediately. And very shortly, once we get this code that you guys see right here, right now, online, here in like the next week or two, you'll be able to lease the models yourselves, pay the validators that are running the hub to run whichever model you'd like, and so it works in Cursor right now, and works in every OpenAI application. So now this next phase is like build out business development, get sales teams. That's kind of the next phase of what we're going to be working on at Manifold. So yeah. Open Tensor on 3,
Maybe at the end of the call. Wicked, guys. Like that seamless integration with things like Cursor is going to make all the difference for getting these billions of tokens across the finish line into people's computers, etc. And getting a wide variety of models is going to be fantastic as well. Like I think this is probably the first time where we can compete with something like OpenRouter, and I think that's fantastic.
And also we can plug directly into OpenRouter. So, Subnet 4 can be a provider on OpenRouter as well, right? So that's also a really great place to get organic tokens. So, Alex, if you're listening to the call, we're not competitors. Let's be friends, Yo, hit my line.
Yeah, I can reach out to him. Let me invite him to the call right now.
Yeah. No, well, we called him. We talked to their team a couple weeks ago to become a provider there. So, but also, we'll on Targon Hub, you'll be able to access it no matter what. But really, like once we have hundreds of models, like the whole pipeline I imagine for Bittensor right now is like you go to like a macrocosmos like fine tuning subnet, you fine tune a model based off your data set and whatnot. Once that fine tuning job is done, you upload it to Hugging Face. Then you put the Hugging Face ID into Targon Hub, and now you've just gone from fine tuning. You can take the pre-trained model from Subnet 9, fine tune that model on 37, and then deploy that for inference on Subnet 4. This is kind of the vision that I see kind of playing out here on Bittensor, and so really just trying to drive that outcome as much as we can, and really hammer that into the ground, like really try to get that done. We think that we'll have all this ready to go by the end of the quarter, where we're good, doing, our goal is to do at least 60 billion tokens a week, by the end of the quarter. But obviously I want to hit 1 trillion if we can. So
hoorah. Great. Okay, well, why don't we close down this, guys? That was an awesome presentation. But if you want to stay up on the stage, Sammy and I, we're going to have a bit of a debate. Anybody else who wants to come on stage is welcome. We're going to talk about root network emissions. Rob, you might have some perspective on this, some thoughts.
I always got perspective for you.